Hello everyone, I'm Kristel and Celemin from the Batangas State University, Alangilan Campus, taking Bachelor of Science in Information Technology from the section 2105.
This video is all about the compilations of the activities in chapter 7. So let's start with the first activity. So the first activity is all about the binary to decimal conversion activity. So instruction. This activity allows you to practice 8-bit binary decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. So convert the binary number shown in the octet to its decimal value. So our octet is this one. Octet, it means 8. So we will put the answer here. So this one is the binary. So this one is we will convert into decimal. So what we will do is to add the numbers in the binary that has 1 in the position. So it's like here. So 16 is the only number or the position that has 1. So it is obviously the answer is 16. So let's check. Correct. The decimal value you have entered is correct. Please click new number to continue. So new number. So the 32 has 1. So we need to add the 32 plus the 8 has also 1. So plus 8. And then the answer is 40. So let's check. So it means that the 0010100 has equivalent to 40 in decimal. So new number. So this one. So the 128, the 16, the 8, and the 1 will get the sum of those numbers. So it is 128 plus 4 plus 16 plus 8 plus 1. So the answer is 153. 153. So let's check. Correct. The decimal value you have entered is correct. Please click the new. So let's try one more time. So let's add the 64, 32, 16, and 2. So it's 64 plus 32 plus 16 plus 8 plus 16 plus 2. So 114. So correct. So we will now proceed to the next activity. So this activity is decimal to binary conversion. So a while ago we convert the binary into decimal. So what we are going to do now is to convert the decimal number into binary. So instruction is this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversion without error. Convert the decimal number shown in the decimal value row to its binary bits. So a while ago we put the numbers, the position that has 1, then we add that, then we put it in the decimal value. So now it is the decimal value. We will now make it binary. So we will just put 1 here in the position that has a total or a sum of 75. So obviously 128 is not, because 128 is larger than 75. So 64, we can use the 64. So 75 minus 64 is 11. So we only need 11. So to convert it into binary, so we only have 11. So 32 is greater than 11, so that's why we will put it here 0. Then 16 is also greater than 0. Then 8, we can use 8, so we will put 1. So 11 minus 8 is 3, so we only need 3. So 4 is greater than, then 0. 2 is, then 2 and 1 is going to use. So let's check. Correct. So the binary values you have entered for all positions are correct. So let's try a new one. So 210. So obviously 210 is greater than 128, so we can use 128. So 210 minus 128 is 82. So 64 is still, we can use the 64, so that's why I put here a 1. Then we only have 18, so 32 is greater than 18, that's why I put here 0. Then 16, we can put 1 here because 16 is less than 18. So 18 minus 16 is 2. So we will use 2. 0, 0, then 2. We will put then 0. Then check. Correct. So another number. So 57. So obviously 128 is greater than 57, so we will put 0. The same as 64. Then 32. We can use 32. Then 57 minus 32 is 25. So we can use 16 because 16 is less than 25. So 1. Then we only have 9 remaining. So we can use 8 because it is less than 9. Then 8, we just need a 1. Then 0, 0, and then 1. So let's check. Correct. So last example. So 87. 1 to 8 is 0. We can use 64. It's 87 minus 64. It's 23. So obviously 32 is greater than 23, so let's put 0. 16. You can use 16. So we can use 16. The answer, the remaining is 7. So 8 we cannot use it. So 0. 4. Yes. Yeah. So we only have 3. So it's all 1 here. So we'll now proceed to the next activity. So what we'll just do here is that we put 1 to the position that it will have summation of our decimal. So next one is this one. So activity ending. To determine the network address instruction, use the ending process to determine the network address in binary and decimal formats. So we have here the host address 28, 189, 226. Then subnet mask 255.245.248.0. Host address in binary. And then the subnet mask in binary. Network address in binary. Then the network address in decimal. So we will answer first the network addresses in binary. So this one is the rule. So 1, I will use 1 as true and true. Then 0 is to false. So in and, so if the 2 has a 0 or false, it will automatically be false. So if it is both true, the answer is true. But if it is true and false, it will be false. So it's like if 1 and 1, it is 1. Then if it is 0 and 1, it is obviously 0 or false. So let's start this one. So 1 and 1 is 1. Then 0 and then 1 is 0. Then 1 and 1 is 1. 0 and 1 is 0. Then 1 and 1, 1 and 1, so 1, 1. Then 0 and 1, 0. And then 0 and 1, 0. So the next one is 0 and 1. 0 and 1, 0 and 1. Obviously, it is 3, 0. Then 1 and 1. Then 1 and 1. It is obviously 1. And then 1 and 1, 1. And then this one is 0, 1. 0, 1 is 0, 0. Next one is 1 and 1. 1. And then 0 and 1. 0. Then 1, 1, 1, 1. So it has 3, 1. And then 1 and 0 is 0. 0 and 0 is 0. Then 1 and 0 is 0. Next one is, we can see here that it is all 0 or it is all false. So as I said before, that if it has a 0, it will automatically be 0. So we can conclude here that this one is all 0. So what we will do now is to convert it into decimal. After we got this binary, we will now convert it into decimal. So what we will do is, this one is 128. So we will put the 128 plus. So since that 64 is 0, then we will not add that. Then the 32 has 1, so we will add the 32. Then the 16 is 0, that's why we will not use that. Then 1 is 8, then we will add the 8, and then the 4. We will add 4. The answer is 172. Then here is 128 is 0, 64 is 0, 32 is 0, then it is 16. So 16 plus 8 plus 4. So the answer is 28. Then here is the 128 note 64 because it is 0. Then this one is 32 plus 16 plus 8 plus 16 plus 8. So it is 184. Then obviously we can see here that it's all 0 and the answer is 0. So let's check. So correct, the binary and decimal version of the network address are correct. So we will now proceed to the next activity. So this is the next activity. So activity unicast, broadcast, or multicast. Instruction. So click start to view the destination IP address. Next, click the host, which will receive a packet based on the address type. So it is unicast, broadcast, or multicast. This is timed activity. So as I click the start button, there will have destination IP address that will appear here. So what we will do is to click the PC that has the IP address, the same IP address. Go. So if the IP address is we can see here, so we will not click, and so it has a time. Then let's try start. So 192.168.100.25. So you have successfully identified the transmission type. So if the IP address has a last number of .255.255, we will click all the PC. So let's reset. Then start a new one to try. So 237.199.126.17. So this one and this one. So you have successfully identified the transmission. So it's like that. So let's start another one. 192.168.100.5. So it's correct. So we cannot see here the destination IP address, so that's why I didn't put anything, or I didn't click PC. Then let's try another one. 237.192.126.17. So correct. So we will now proceed to the next activity. This one is the pass or block IPv4 address. Decide to pass or block each IP address depending on whether it's public or private. Click start to click or either pass or block. So if after we start here, we will just decide if it is we will pass or block. So correct. You have successfully identified public and private IP addresses. So let's proceed to the next activity. This is the next activity. So activity public or private IPv4 for address. So instruction is drag each IP address to the correct category, public or private. So we will just categorize the IP addresses here if it is the public or private. So 172.16.35.2 is private. Then the next one is 192.168.3.5 is private also. Then the 192.0.3.15 is, I think it is public. Then 64.104.0.22 is public. Then the 209.165.201.30 is private. So let's try if it is correct. So 192.168.11.5 is private also, and then the 172.1.16.30 is public, and then the 10.55.3.168 is private. So let's check. So we have wrong here, so maybe it is here and then here. So let's check. So correct. Our answers are all correct. So we will now proceed to the next activity. So this is the next activity, IPv4 issues and solutions. So drag the IPv4 and IPv6 terms to the field next to the appropriate description. So the description is 128-bit address /340 undecillion addresses. So it is the IPv6 or the IP address version 6. Then the 32-bit addresses or the 4.3 billion addresses is the IPv4. Then transports an IPv6 packets over IPv4 network. So that is the tunneling. And then uses NAT64 to convert between IPv6 and IPv4. So that is the translation. So translation and convert, so it sounds the same. Then the next one is allows IPv4 and IPv6 to coexist on the same network segment. So dual stack, they can coexist in the same network. So it's dual, the same. So let's check. So correct. All answers are correct. So let's now proceed to the next activity. So guys, this is our last activity for the chapter 7. Activity, identify types of IPv6 addresses. So instruction is drag the IPv6 address type to the most appropriate description. The first description is unique, internet routable, IPv6 address, dynamic or static. So the answer is global unicast. Then FE80, then double colon, then 1 is link local. The next one is 2001 colon DB8 colon ACAD colon 1/64 is the global unicast. Then typical IPv6 prefix used to indicate the network portion of the address is the /64, then used to communicate with other devices on the same IPv6 subnet. So that is a link local. So let's check if our answers are correct. So correct. So that's all for this video. Thank you for watching.